Okay, I think that everything's working. So, hi, this is my first math guy doing this. I haven't really done this before, and I know that the setup that I have is kind of ugly, but yeah, it's gonna work hopefully for now. We'll see if I have any fixes that can be made. But, anyways, so what we're going to be doing is just taking a math test, 30 minutes timed, and then I'm just going to go over every problem and show you how you should actually do it, in a reasonable amount of time. I'm going to be taking the math test along with you guys. There's a recording my calculator on screen and the math test. I'd appreciate it if you wouldn't look as I'm taking the test. Well, you're also taking the test. This is just in case you want to see, how do I put this? If you want to go back and see how I'm actually taking the test within the 30 minutes. Okay, so the link will probably be down below somewhere to access the math test. For this first one, because also I'm out of practice, and for a few others, I'm probably going to include this crunch kit in the docs, which basically has all the useful formulas that you can use, that you'll probably need for the test. You won't have this on the test, but by then you really should have most of the important ones memorized. At this point, though, I'm not really expecting you to. Okay, so let's start. Uh, do as many of the questions that you can in 30 minutes. Skip ones that you don't know how to do, and hopefully use your calculator well. Good luck, and we are starting now. I'll give reminders when needed. 20 minutes left. 6 or so minutes left. 1 minute and 30 seconds. Start finishing up. Now is the time to randomly bubble in all your answer choices. $10. Make sure everything's bubbled in at this point on the test. And time. Oops, that's loud. Ooh, sorry about that. That was louder than I expected. Okay. So. Okay. Now it's time to start correcting. I definitely got some things wrong, but we shall see. Let's see. I'm just going to start correcting. Take the time, just take the time to correct along with me, and then you can skip forward to when I'm done. Okay, I'm done correcting at this point, so now I'm just going to go over it. As far as I can tell, I think I got... Sorry, give me a second. Where's my pen? There it is. 1, 2, 3, 4 wrong. Out of those 4, only one of them was one that I thought I knew how to do, but I did wrong. The other 3 were guessing, and I actually got one that I guessed on right. So that's always why it's important to guess. Okay. Now it's time to review. Oh shoot, my phone's out of battery. Give me a second. Well, that's not good. I'm going to pause the recording until I can get my phone back up and running, because that's useful for the calculator. Okay. Now, phone's charging. Hopefully not dying right now. It isn't. Okay. So now let's get back to correcting. So for number 1, this is one where by the point of the test, this is one that you should be able to do fast, but it's pretty normal that, like, you know, when you first start out, you're not going to know this one. So if they ask you the probability of a data point falling between 2 points here, there are 3 identities that you're going to need to know, which are, there's a 68% chance or so of something falling within 1 standard deviation, 95% within 2 standard deviations, and 99.7% within 3 standard deviations. So let me see, can I draw out a chart? Okay. So if we imagine, you know, our standard deviation graph right here. That's our mean. And let's say we have a standard deviation of, let's say our mean is 200. This is definitely not to scale. If we have a standard deviation of 50, then let's say we have our point 150 here. So this is like 1 standard deviation away. And we have 250. Hopefully you guys can see that. 150 here. Let me go point actually and make that bigger. 150. It's weird that I can actually like draw and put like pressure to make the text more visible. 250. So there is a 68% chance of our number falling between 150 and 250 if we have a mean of 200 and a standard deviation of 150 or of 50. Sorry. There is a 95% chance of it falling between 100 and 200 because, or 100 and 300, because 300, that's 2 standard deviations away, like in front of, and 100 is 2 standard deviations, you know, that way. So that would have a 95% chance. So here, what we see is 560 and 1405 with a mean of 250 and a standard deviation of 845. Now, when you're doing these problems, you usually should recognize that this kind of thing is going to probably be an even number of standard deviations away. They're not going to give you something like 1.5, 2, that kind of thing. So it's pretty easy to recognize, and as you see, I probably did this pretty quickly. 2250. Fuck. My calculator, it's annoying to press the 0 button. 845. That gives us 1405. So 1 standard deviation away that way is 1405, but 560 is 2 standard deviations. So if we have, you know, that is 1405 in the 2250 in the middle, 1405 and 560, they want us to find this area. So the trick that you need to recognize here is 2 things. So first of all, you actually want to first subtract, I guess, 95% minus 68%. And the reason that we do that is because that gives us 27% chance. There's a 27% chance that something falls farther than 1 standard deviation away, but less than 2 standard deviations away. So that would be like in our previous problem where we had 100, 150, 200. There's a 27% chance that something falls between 100 and 150, or what is this? 250 and 300. But we only want it between this area over here. We don't care about, this area over here. We don't care about that at all. So we divide this by 2. And that gives us 13.5%. If they said, let's say, between 3, if they said, let's say, if we do another subtractive, let's say 2250 minus 845 times 3. If they said between negative 2, if they said between negative 285 and 560, which is, a z-score of negative 3 and a z-score of negative 2, that would be 99.7 minus 95 divided by 2, which is, yeah, come on, 0.7 minus 95 divided by 2. Oops, I did that wrong. You have to divide the whole thing. 19 divided by 2. That'd be like 2.35% chance. And that's how you do that. Okay. So this is a combinations problem, or is it a permutation? I think this is actually permutations. So normally with a regular permutation, where if you have, like, let's say 5 people sitting in a line, this right here would just be 5 factorial different ways that they could be sitting together. You factorial on the calculator is 5, and then you go math to probability down to that little exclamation sign, 5 factorial. Factorial basically is repeated multiplication. So it's like 5 times 4 times 3 times 2 times 1. 8 factorial is 8 times 7 times 6, blah, blah, blah. You get the idea. So if we had 8 people sitting in a line, the first thing that you would want to jump to is 8 factorial. However, because they're in a circle, there's actually a small adjustment that you make for any time you're dealing with something in a circular situation. Not sure if this rule is actually up here, but with a circle, you want to do n minus 1 factorial. So, n minus 1 factorial. But and that would just be in how many ways can, let's say, 8 different people be seated in a circle. It'd be 7 factorial. Wait, how do I'm going to erase some shit over here. We don't need that. So it would be 7 factorial, which gives us 5,040. Obviously, that's not the right answer. The correct answer is 1440. For this, there is something else that they confound us with. If one pair must always be seated together. So that means, if you can imagine it, we have, let's say, 1, 2, 3, 4, 5, 6, 7, 8. And, like, these are all different people. So we have person, like, let's say A, B, C, D, E, F, G, blah, blah, blah. But these 2 people always needed to be seated together. And this is a little bit tricky. There's not really like a universal formula for doing these combination and permutation problems. But the trick here is you want to treat this pair as basically one person. So instead, we kind of have, in effect, 7 individual objects. This pair and then these other 6 people. We have 7 individual objects. So that gives us 7 minus 1 factorial. Different ways that they can be moved around. Or 6 factorial. They are basically a separate, they're a single object except for one thing, which is that these 2 can be, like, let's say, swapped in order. So you could have person A and person B over here. Or you could switch that so it's person B and person A in the other order. So for that, we multiply it by 2, because that means like twice as many different possibilities. So the answer is 6 factorial, times 2, 1440. again, you're not expected to like pick all of this up like immediately. It's just like, you'll get the hang for these kinds of problems as you do more and more of them. Okay. So now we move on to problem 3. It's also like, this kind of thing, if you're struggling with it, if you don't know how to do this immediately, skip on to the next problem. Like, I instinctually know how to do this one, so I attempted it. But, like, even I skip problems sometimes. It's like, nope, that's going to take me way too much time. That's perfectly fine. So, a game can end with a probability of 2, 4, or 6. It has an expected value of 3.6, and the probability of a payout of 2 is 0.4. So, for expected value is basically the probability of event A times basically the value of event A plus the probability of event B times the value of event B, etc., etc. So like, let's say you flip a coin. If it gets heads, you get $10. Heads, $10. And tails, $5. Tails, you get $5. That kind of looks ugly. $10. There we go. The expected value of this outcome, let's say you flip the coin one time, how much would you be expected to get? That would be 10 times 0.5, because there's a probability of 50% that you get heads unless the coin is rigged somehow, plus 5 times 0.5. Or 5 plus 2.5, so $7.50 is the expected outcome. So, also another trick that you want to use with dealing with probabilities. When you're dealing with like a single event, kind of, a single like flip, a single probability like distribution, whatever, all the probabilities sum up to 1. And because, there's, if you sum up all the different probabilities of everything happening, it has to sum to 100% that at least one of them is going to happen, if that makes sense. So, we have, a game can end with a probability of 2, 4, or 6. It has an expected value of 3.6, and the probability of payout of 2 is 0.4. Find the probability of a payout of 6. So we have EV, the expected value is, let's say, 2. So we start with the payout of 2. The probability of a payout of 2 is 0.4. Plus 4 times, for now we're just going to leave this as probability of 4, plus 6 times probability of 6. The probability of a payout of 6. That's what that means. We also know what the expected value here is. It's 3.6. That's what you're expected to earn on average. So we have 3.6 equals 2 times 0.4 plus probability of 4 plus 4 times the probability of 4 plus 6 times the probability of 6. So, there is one other thing that we know that we can relate these two to each other. The probability of 4 is going to be equal to 0.6 minus probability of 6. Because we know that there's a 40% chance of the, or actually let me write this another way. Probability of 4 plus probability of 6 equals 0.6. Because we know that there is a 40% chance of a payout of 2. So that means that the combined chances of a payout of 4 or 6 has to be 60%. So what we can do is we can substitute out one of these. So we can, we ideally want to solve for probability of 6. So we say P6 equals 0.6 minus P4. So we get 3.6 equals 2 times 0.4 plus 4 times probability of 4 plus 6 times 0.6 minus probability of 4. Now I know you're wondering, how do I solve this out in time? What I actually did when I was taking this test is I did no algebra here. I used something called a numeric solver. Oops, my phone got unplugged. That would have been bad. Where basically you go, if this is on a lot of calculators, ideally you're using a graphing calculator for this. Using a graphing calculator is basically necessary for the academic test. I know it's annoying, but you need it. I'm using a TI-84. If you have an Nspire or one of the other calculators, figure out where this function would be found. But here you go to math, then solver. Note on some older calculators. Oh wait, shoot, is it not appearing? That's weird. Give me a second. Why is it not linked up? Okay, wait, my device got disconnected. God damn it. Give me a second. Start now. Okay, there we go. Ugh, that's annoying as hell. But in any case, you go to get there, you go to math, solver, B, and then numeric equation solver. Let me go and turn off a little bit. Whatever. Okay. On some devices, you'll see that you don't actually have E2 box. So you're going to need to set up everything in terms of 0. You can do some simple algebra to do that. And basically what this lets you do is solve for one variable. I'll show you guys how to do it this time because, I probably won't have time to do this on every test, on every question. But so in this case, what we're going to want to do is P6, or we don't have P6, we have 3.6 equals 2 times 0.4. On my phone, it's a little hard to press some of the buttons, so that's why you see me pausing. Plus 4 times, let's say, x for P4, plus 6 times 0.6 minus x. And that way, it's setting everything up in terms of one variable. Then you press down to go to OK. And then, oftentimes, you can actually set this up for multiple variables if you want to plug in different values. On the one that you actually want to do, you press alpha and enter to solve for it, and you get 0.4. And 0.4 is for plus. Wait, did I do this? I feel like it's in any case. 0.4 is the probability of. Ooh, I messed that up somehow. I think, yeah, I did this wrong actually. I set this up in terms of P4. So P4. So this is actually a probability of P4. The test is asking us for the probability of P6. So, but you know that if the probability of P4 is 0.4, the probability of P6 has to be 0.2 because, you do 0.4 plus P6 equals 0.6, 0.2. Okay, that's how you do number 3. Number 4. This is another expected value question. Let me go and erase some of this stuff. Oops. Let me go on. What did I do there? Okay. So, for this one, we have the expected, it's asking us to just find the expected value. Now you may say, wait, there's no probabilities. Well, we don't actually need probabilities every time for expected value. What you can do here is basically, it's kind of like the equivalent to a mean. So we know that expected value is like the sum of, let's say, PA times VA plus PB times VB, etc. But we can actually basically break this down into probabilities intuitively. So if we have, let's say, n number of times instead, when you see like number of times instead of just actual probabilities, you do the number of times of that specific event. So NA times VA plus NB times VB, on and on, NC times VC, VB means value of B, VA means value of A, blah, 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 of event A, And then you divide it by the sum of all the numbers. You divide everything by basically NA plus NB plus ... And that basically actually gives you the equivalent. That's the same formula for expected value. Mathematically, it works out to be the same. So here what we do is 4 times 3 for the first event plus 3 times 5 plus 5 times 2 plus 7 times 2 That gives us a 51. Then we divide that by the sum of all the number of times. So we have 3 plus 5 plus 2 plus 2. 4.25. And this works because basically NA divided by the sum of all of these is actually the same as probability of A. Because 3 divided by 3 plus 5 plus 2 plus 2 gives us 0.25, or the probability of this event happening is 25%. Yeah. Okay, next problem. For this, there is only one thing that you should honestly do. Plug this into your calculator. This is what I would do. If you should just be able to do this really quickly. So this is what you want to do. Math. Scroll up, or down, I guess. You go to 0 where it says summation this. It gives us n. I like to do x. It doesn't matter as long as you keep everything the same in terms of just like using x instead of n. X is just faster for me to type. So I say x equals 1. Then for infinity, you do not want to use infinity. I'd say the highest I'd recommend going is 100. Even that kind of I wouldn't really even recommend it. Maybe something like 50 would work. And this is just getting us an approximation for the infinite sum. Then you do 16 times 1/5 to the x. And I'm just going to test all of these down the line. And that gives us actually just 4. So boom, we already know the answer is A. If we try out all the other ones, we get 16 times 1/4 to the n. That gives us 5.33. That's clearly not it. 20 over, and you actually would know pretty quickly that the next one is basically, what is this? 20 divided by 5 to the x. That's clearly not it. If I was to do all of these in order, but I don't feel like it. Okay. Number 6. Do not do number 6 up front. Unless you really feel confident. I'm going to come back to that one later. Do not do it up front. I skipped it because I was like, that's going to take me far too much time. Okay. Number 7. An arithmetic sequence has A1 equals 22 and A equals 43. Find A 15th. So, where's my pen? Oops. Okay, there we go. So, the trick for an arithmetic sequence, you have AN. This is the general form for an arithmetic sequence, equals A0 plus, let's say, what is this? R times N. R is just a constant, basically the slope. So A1 is equal to basically A0 plus R times N. Or the alternative one, which is usually more useful, you just need to keep track of everything. A1 or AN equals A1 plus R times N minus 1. You basically just need to do an offset there. So like an arithmetic sequence, let's say if you have an A0 equals to 5 and A1 equals to 8, can you guess what R will be? R is going to be 3. It's going to be the difference between these two. If you have, let's say, A2 equals, then A2 would be 11, A3 would be 14, etc., etc. So for this, what you want to do is quickly find out, okay, what's R? That's the first thing you want to do with these problems. So for that, what I would do is you have AN equals, A0 plus R times N. I generally don't actually think of this formula. I just think, okay, you need to find the difference between those two terms. And then I'm going to divide it by the distance between them. So 43 minus 22. That has a distance between them of 21. I see that the distance between A1 and A8 is 7 because 8 minus 1. That means that basically R was multiplied by 7 times, to get that. So I divide it by 7. So I find that R is equal to 3. Then, if I want to find A15, I say, okay, A15 is going to be equal to 22, because that's like, the first term I start with, plus 3 times, pay close attention to this, 14, not times 15. It's 14 because we're not starting at A0. And that gives us 64. That's an arithmetic sequence. Okay, now number 8. I'm going to see how they explain number 8, because apparently I did it wrong. Okay, so yeah, I guess I misremembered the annuity formula. Sounds like something I would do. Actually, let me go look this up. What is the annuity formula? I'm going to switch to Chrome. Oh, okay. So I didn't really misremember it that much. Future value. It's actually, you want future value, not present value. Okay. This is the annuity formula. I feel like I should probably skip this. You should probably go. You should probably review this later, but I'm just going in order. So you have the periodic payment r to the n minus 1 over r. Just the rate per period. Okay. Let me go back to the notes then. 1 plus r to the n. So that's what I messed up on. You need to make sure that you're keeping your periods correct. So, actually, I'm going to skip this. Do you mind if I'm going to come back to it later, because I really kind of want to go over some more of these like the regular problems before I do it. I'll link into the timestamps below, hopefully, where I'm going to come back. Yeah. Okay, number 9. Population increases from 900 to 1500 in 25 years. Assuming constant exponential growth, what will the population be in another 11 years? So for this, we have, let's say, y equals p e to the rt. So when you're doing these problems, there's a few things that you really need to remember. You need to remember the principal, or, the initial amount given, the rate, which is basically the rate of growth, and time, which is the time period. Note that rate of growth and time are also kind of dependent on n, where n is basically the period of time. So you want basically everything to be in terms of like the same n, depending on which one they give to you. So if they say an n of years, you want your rate to be the annual interest rate, growth rate, whatever. If they say then time is in years, and like basically n, which you'll have in non-constant, that's going to be in terms of years. But if they say monthly, then you want your time in terms of month, your rate in terms of months, and n in terms of months. But we will see. Okay, so we have P is 900 times E. Our rate is what we're trying to first solve for, because they don't give that to us initially. R, and they give us 25 years. So 25R. 1500 equals 900 times E to the 25R. I'm going to put this in my numeric solver again, because I don't feel like doing algebra, and it takes too much time, and this is usually more reliable. I'd always recommend use numeric solver when possible. I'm just writing the things out because like it's important for me to do so that you guys can see it. But like on the test, you want to actually write very little on paper. Everything should hopefully be going straight into your calculator. Okay, so that gives us an x of 25, or 0.0204, blah blah blah, which means it's a 2% or so growth rate. Now I'm going to use a little trick. Assuming constant exponential growth, what will the population be in another 11 years? So when you actually do this, it actually saves the x in your calculator. So you can actually or the value that you solve for in your calculator. So you can actually come back to it later, which is super useful. So I'm going to quit out of numeric solver because we don't really need that anymore. 1500 now is the base I'm starting with, times e to the x times 11. Now note, we actually saved what x was because it saves in the numeric solver. And that gives us 1878. Alternatively, what we actually could have done was we also could have done 900 times e to the 11 times, what is that? 25 plus 11, 36. That gives us the exact same result. Entirely preference which one you want to do. And that's how you do that one. Okay. So the z-score of something is going to be z-score is equal to basically value. Let's see, I think that they want us to write it as x. It's going to be the value of something, or like the point that you're given, minus the mean divided by the standard deviation. And what z-score represents is, this is important for you to remember intuitively, basically the distance from the mean normalized in terms of the standard deviation. So if something has a z-score of, let's say, 1, if a point has a z-score of 1, that means it's one standard deviation to positive of the mean. So if you have a mean of 1500 and STD of, let's say, 50, then something with a z-score, something that has basically a point at 1600 is going to have a z-score of 2, which means it's 2 standard deviations positive of the mean. You can also have negative z-scores. If something has a z-score of negative 3, that means it's like 3 standard deviations away to the left of the mean, or less than the mean, blah blah blah. So what they actually give us the z-score here, but they want us to find the variance of the grades. So you get theta. So also a very important thing that you really need to have memorized, burned into your brain by the time you're taking the test, is a variance equals standard deviation squared. So if you have a standard deviation of 5, the variance of that is going to be 25. If you have a variance of, let's say, 36, the standard deviation is 6. So initially we solve. So we get we have, what is this, 85 minus 72 over standard deviation is equal to a z-score of 0.7. You multiply standard deviation up there, divide by 0.7, and you get 85 minus 72 divided by 0.7 equals the standard deviation. Okay, so if you do that, 85 minus 72 divided by 0.7, that gives us a standard deviation of 18.57. Great, we marked that. No, they want the variance. I almost made that mistake. Lucky me. 344.9 once you square that, because squaring standard deviation gets you the variance. And yeah, that's how you do it. Okay. Number 11. Normal distribution has a mean of 37 and a standard deviation of 5.5. What is the probability that a given data point will be above 42.5? I feel like I messed this up. Okay. Now, I actually didn't. This is something where I thought I'd messed this up. Okay. So a normal distribution, blah, blah, blah. So intuitively what you should go to, okay, how many standard deviations away is 42.5? If you do a quick look, it looks like it has a z-score of 1 or so. Z-score of 1, and it's 1 standard deviation above. So the identities that you should come back to are 68% 95%, and 99.7%. So 1 standard deviation away. So it's asking what is the probability that it's above 42.5. So it's like this area under the curve here. Now the way that you calculate is simple. We know that the probability that a data point is within 1 standard deviation is 68%. So the probability that's not within is 1 minus 68%. So 1 minus 0.68. That gives us 32%. But that's 32% in both directions. So you need to divide by 2 so that it's just in, so that we're only looking at one side of it. So we have 16%. That's the probability. Okay. Oops. Okay. In a binomial distribution with an 87.5% probability and 238 trials, what is the standard deviation of the number of successful trials? So the formula for this, I actually don't even remember the intuition why. Is it in here? Wonder if it is. Okay, the variant, but anyways, this is the formula you want to know for this. I don't actually even remember the intuition why. Variance of a binomial distribution is NP 1 minus P. I don't even know how I remember this actually. This is like 3 years ago, geez. So N is the number of events and P is the probability of it happening. So the variance of this binomial distribution is going to be 238 times 875 times 0.125, which is 1 minus 0.875, which gives us a variance of 26.03125. That is the variance that is not the standard deviation, so we take the square root. 5.102 or 5.1. Okay. Oh shoot, wait, let me go back and see if I can, because I think I accidentally erased everything. There we go. Okay, that's better. Now a 12-sided die, anyways, yeah, NP1 minus P for variance. The 12-sided die numbered 1 to 12 is rolled 8 times. What is the probability that an odd number is rolled exactly 6 times? So for this, what you're going to want here is something that's called a binomial. This is basically a binomial distribution, which is what you need to recognize. Because it's a 12-sided die numbered 1 to 12. And we know it's asking for the probability of an odd numbered die. So basically there's 2 events here. It's odd or it's even. And we know that each of them intuitively has a 50% chance of happening. So the formula for a binomial distribution of a specific event happening, let's say, is N choose NCK, or wait, let's see. So it's the number of times, so let's say K, times the event, times, basically this is the number of times that specific event happens, times 1 times, let's see, times P to the K times, let's say, 1 minus P to the N minus K. So if we, let's say, so in the specific problem, what that means is we have, and also NCR, what you're going to want for this, and if you use NPR at all, you go to math and probability and you see that right there. That easily calculates it out for you. So you have math, 8 choose 6, which basically represents the number of combinations of different ways that the specific event could happen, times 0.5, 0.5 to the 6th, because we want that event to happen 6 times, times 0.5 squared. Because that's 8 minus 2, 6. The number of times that doesn't happen. 0.109. I think that there's actually also a way to do this in the calculator. Where actually, I think it's binomial PDF. So this actually might be easier for you to remember. I like doing it the old-fashioned way, though. Where you input the number of trials, which is 8. The probability of that event happening, which is 0.5. Come on, aren't you working? 0.5. And then the number of times that event happens, which is 6. And that gives you 109,375. Yeah. 0.109,375, or D. Okay. So, a geometric sequence with common ratio -3 has 8 terms and a to the 1 equals 2. Find the largest term. So, this here, a geometric sequence is slightly different. So you have basically an equals, let's say, a0 times, I guess it's r to the n. So it's to the power of it. So basically, what that means is that you multiply it by the ratio every time. So let's say you had the ratio as 2, and you started off with a value of 4. Or let's say a1 was 4. R equals 2. A2 would be 8. A3 would be 16. A4 would be 32, etc. So here what we have is a ratio of -3 and 8 terms, and a1 equals 2. Find the largest term. So honestly, this is what I would do, is just put this in the calculator. So what's tricky here is that we have a negative number. So it's actually going to flip in sign every time. So what we want to do here is we want to do, let's say, a1, or we're going to do, so 2. The formula here also could be an equals a1 times r to the n minus 1. Same thing, basically, just setting everything up in terms of a1. And that's what we're going to use here. So we have 2 times 1, or 2 times -3, because the ratio is -3. Make sure it's in parentheses. To the, and let's say the 8th term. Let's test if that's the largest. 8 minus 1. Because we're starting at a1. No, yeah. That gives us -4374. Clearly not the largest. I guess the last term was negative. So let's try going down to and testing what a7 is. That gives us 1458. So that's our correct answer. Okay, let's scroll down. I accidentally copied that twice, so that sucks. How many ways can a library book choose 8 books, select 8 books to purchase from a list of 14 books? So here's where I'm going to give a little lesson on permutations versus combination. Geez, my device connected just again. I think it's because my phone unplugged, so. Give me a second, just checking some messages, that kind of thing. Okay. I really need to not let my phone disconnect. That screws everything over. Start casting. Okay. And we're back. So we have permutations versus, where's my device? There we go. Combinations. So a permutation, you want to use NPR, permutations, where order matters. So that would be something where it's like the specific order of something matters. Combinations is where order doesn't matter. So one example I remember on a test is where they give you, let's say, president, vice president, and secretary. 3 positions. And there are 14 people, let's say, in the class, and they're choosing a president, vice president, and secretary. How many different combinations of these people are there? Or how many different ways could you choose from everybody? This here is a permutation because the order does matter. So we would do 14 times 14p3, 2184 different permutations. But combinations would be something where it's like choosing 3 council members, where it's like it doesn't really matter who's who. That would be 14 choose 3. They're slightly different mathematical formulas. I don't really feel like explaining them. So that'd be 364 different ways. So it's like if we have, let's say, Dylan, Kayla, and Ryan, it matters for president, vice president, and secretary who these people are. It matters, if that Dylan's in this spot here while Kayla's in the spot here. It would be a totally different combination if you flip them around. But if these were just 3 council members, the order of them doesn't matter. Does that kind of make sense? So here, the order really doesn't matter that much here. It's, intuitively, you can just say, yeah, I don't think it really matters which different way which book chosen first on the list. You're just choosing 8 books. So that would be combinations. 14 choose 8. So 3003. There's no other complications here. Okay. Number 16. In a group of 490 alpacas, it is expected that 235 of them will be spat at by approaching strangers. What is the probability that Daniel will not be spat at by a random alpaca? So, kind of a weird, this is a weird problem, but there's one thing, they're trying to get you to understand a simple thing here. There's one thing that this is testing. So, the probability, if we divide 235 by 490, 235 divided by 490, come on, is 47.9%. That is the probability that Daniel is spat at an approaching alpaca. However, we want the probability that he's not spat at by a random alpaca. So that would be the not of that, and for that we do 1 minus that probability. Because, if there's a 30% chance that you're going to get the vaccine tomorrow, the chance that you don't get the vaccine tomorrow, that you don't get vaccinated tomorrow, is 70%, if that makes sense. Now, 1 minus... That's 52 the probability that he's not spat at is 52.04%. So 0.52. Okay, so let's move on to the next one. Okay, in a group of 490 alpaca, 17. A cafe offers 6 types of coffee, 3 types of eclairs, and 4 types of food bowls. In how many ways can 2 people order one of each item? So let's first look at the simpler case. How many ways can one person order one of each item? This is the multiplication principle, where basically you multiply different probabilities or combinations by each other to end up with the total. Assuming these are all independent, because there's 6 types of coffee, there are 6 total different combinations of just coffee that one person could order. Now that we add in eclairs to the mix, that's 18. They could order, let's say, coffee A and eclair A, coffee A and eclair B, coffee A and eclair C, coffee B, eclair A, blah, blah, blah. You go down the list. So there's 18, 6 times 3. When you add in fruit bowls, that's 6 times 3, times 4. Or 72 different combinations that one person can order one of each item. Now, for how many ways can 2 people order one of each item? That is basically 72 squared. because each person has 72 different ways that they can order one thing. So basically you multiply the two together. 72 squared. 5184. That's the answer. Okay. So this problem. Honestly, I don't like this problem. Isn't really something that you're going to see on a test, but I like nerding out about it. Just because this is a fun thing that I learned on my own when I was doing it. Like, and that's like, wow, that's a really convenient way to do the specific type of thing. So what they really want you to do is sum up all the different combinations of blah, blah, blah of coefficients that there are. Use like Pascal's triangle or something. But there's actually a really easy solution for this, which is that this. If you imagine that, let's say we multiply everything out. Let's say we do x minus 3 squared. That gives us x squared plus, let's say, minus 6x plus 9. The coefficients are 1, negative 6, and 9. So negative 3, let's say that's 3, 4. The coefficients there are 4. But this is the same as just plugging in 1 into every x here. 1 squared minus 6x plus 9, because 1 squared or 1 cubed or 1 whatever is always just 1. So it's the same as just plugging in 1 squared minus 6 times 1 plus 9. For this problem, if they want you to find the sum of all coefficients, if you ever actually see this on a test, just plug in 1 into any variable and then just do everything out normally. 1 minus 3 squared equals negative 2 squared equals 4. Here, same thing. 1 minus 2 to the 5th equals negative 1 to the 5th equals negative 1. Negative 1. You could do all the math out. I wouldn't recommend it. Yeah. I remember learning that. That's fun. Okay. 7 parentheses 5 divided by 5 parentheses 3. Maybe they want you to do a bunch of complex math. I don't know. All that you need to recognize for this problem is that these little parentheses mean combinations, or 7 choose 5. So for this, plug into your calculator. 7 choose 5 divided by 5 choose 3. Woohoo, you're done. Yeah, just have your calculator do that kind of thing. Okay. So for these problems, whenever you see them giving you a big data set like this, what I would usually recommend is just going into stat in your calculator, and then, it says stat edit. Click on that. Then it's going to give you a bunch of lists. Input all the points into that list. So you have 10, 28, 45, 47, 49. Then you go stat, and then you click on stats again. You go to where it says one variable stats. Click on that. Enter. Make sure that's using the right list that you entered it into. Then it runs and blah, blah, blah. So there's a few things that are important to note here. The little sign over x is basically, that's 30. That's just the mean. Then you have e of x. That's like just the sum of everything. Not super important. Now, it also gives you quartiles and medians, which are usually useful. You might want the median in quartile 1 and quartile 3 if they ask about that. I'm not really going to explain what all of those are, but just so you know. And then there's these two things, s of x and what is that? I forget what that little symbol is. Whatever. The first one is the sample standard deviation. The second one is the population standard deviation. For Academic, they want you to use the second one, which is 14.9. So the one with like the little, this symbol on it. Let me write it up here. It's this symbol. They want you to use that one. Don't use the other one. It's slightly different how they calculate it. So we get standard deviation equals 14.905. And then they want variance, so you do 14.9 squared. You square it. 222.159 or 222.16. Boom. That's your answer. Okay. 21. Oh, I'm getting tired. So for this, this is usually a bitchy problem to do. There's a few things that you want to usually do this through process of elimination. So let's see. You're never really going to want to evaluate the full thing. That's always a hassle. So let's see where we can eliminate. If we look at the let's do the first term easiest. X to the just multiplying out the largest terms. So we have x cubed times 4x cubed times x cubed. That's guaranteed to be the largest term, which gives us 4x to the 6th. So we know it's not going to be this one, 8x to the 6th, or 4x to the 5th. And then we want to basically find for the rest of these, and also you could evaluate out the smallest term, because that's also easy to evaluate, but they're basically all the same. Then you want to find a term here where it looks like they're all basically different, if I can put it like that. So it looks like basically whichever answer you find will eliminate all the rest. I'm going to go with the second largest term here. That looks like it should be reliable, eliminating everything. So if we look at what has to generate x to the 4th values, it's going to be x cubed in the first one. Where's my... Okay, there it is. Sorry. Just trying to find my marker. So that's going to be x cubed times 3x. That's going to be one of them that comes out to having a 4th term, plus 4x cubed on there, and then times 2x. Also, this is negative 3x. Please note that. So it's x cubed times negative 3x plus 4x cubed times 2x. Those are the two that are going to sum up to x to the 4th. Just because the x's come out that way. Nothing else is going to sum up to x to the 4th if you look it over. So we get 3x to the negative 3x to the 4th plus 8x to the 4th, or 5x to the 4th. That eliminates C. That eliminates E. You're left with A. Okay. Okay. Now, 22. A pair of dice are numbered 11 through 16 are tossed. Find the expected value of the sum of the resulting faces. So, interestingly enough, this is just going to be actually just summing up the expected values of each of the individual dice. So, find the expected value of one dice. 11 plus 12 plus 13 plus 14 plus 15 plus 16 divided by 6. 13.5 is the expected value of one dice. So the expected value of two dice is 27. Okay. Find the z-score of 23 in a distribution with a mean of 8.5 and a variance of 4. So for that, we have our z-score. Z equals x minus mean over standard deviation. Variance, standard deviation is a square root of variance, so we know that standard deviation is 2. Mean is 8.5, and it says of 23, so we have 23 minus 8.5 over 2. Also, I like separating it out, and then I just, use ands when I'm typing into my calculator. Personal preference. 7.25. Great. So, 24. Again, just plug this into your calculator. Don't do anything complicated. Also, actually, small error. This should be 3n plus 3n minus 1, not k. They make a few errors like that. Oh well. So we do sum. X equals 1, let's say. I like using x. 4. 3x minus 2. And that's sum. And this is basically summing up for, in case you don't know what a summation is, it's, if we have n, so it sums up 3n minus 2, or 3 times 1 minus 2, plus 3 times 2 minus 2, plus 3 times 3 minus 2, plus 3 times 4 minus 2. If you have, let's say, sum from x equals 1 to 100 of, let's say, x, that's equal to 1 plus 2 plus 3, blah, 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 plus 100. Yeah. Okay. So continue entering it into a calculator, plus sum. And this is honestly the easiest way to do it. I wouldn't recommend anybody actually do this by hand. 2x squared. 194. That's our answer. Okay, 25. I guessed on this one and somehow got it right. I want to see how they did it. There are 12 royals in the deck. Okay, so they messed up. Wait, no they didn't. I'm stupid. I thought for some reason there were 9 royals in the deck. Why did I think that? I was like, oh, once you get rid of ace, I was like, I thought like, I was like getting confused because there's like, 4 different kinds. There's a total of 12, 4 different card colors, like 4 spades, hearts, you know what I mean. And then times 3, so 12. So for here, what you want to do is this relies on something called selection without replacement. So when you do a coin flip, basically what happens is the probability of something happening stays the same every time that you do it. It's just 1/2. But sometimes when you're taking something, the probability of it goes down over time. Let's say that you had 3 red objects, red, red, red objects, and then blue objects. And you want to know what's the probability of, if you selected 3 objects, only selected red objects. At first, it's simple. The probability of taking 1 in the beginning is 3 divided by 6. But then once you've removed 1, your probability of selecting a red object actually changes. Because now there's only 2 red objects left to select. So it's then times, because it's like, sequential here, 2 divided by 5, because there's a total of 5 objects. Then once you've removed that last red one, it is times 1 divided by 4. So it's actually 0.05, which is different than just if we did 1/2 cubed, which would be 0.125. Hopefully that makes sense. So here we actually need to change the probability slightly every time that we select it. So at first, it's 12 divided by 52 is your chance of selecting a royal. But then when we select another card, it's now 11 divided by 51 times 10 divided by 50 times 9 divided by 49 times 8 divided by 48. Alternatively, I guess that you could write this as, no wait, also this is 8 actually. 1, 2, 3, 4, 5, yeah. So that's 8. Alternatively, you could write this as 12 factorial divided by 8 factorial times 48 factorial. Oh wait, no, it's actually 7 factorial. 48 factorial divided by 52 factorial. And basically, when you divide factorials like this, this is actually wait a second. Is this just actually 12 P7 or 12 P5, I guess, divided by 52 P47? No, wait, it's actually 52 P5. It is, huh? That's the permutation formula is actually n factorial over n minus, I guess, r factorial for n choose r. And that actually gives you, so it actually, this is the same thing because 12 factorial divided by 7 factorial. When you divide factorials, it's, the way it works is like, let's say we have 5 factorial divided by, let's say, 3 factorial. That's 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1. So it's just 5 times 4, if that makes sense. It kind of cuts off the bottom numbers. Interestingly, yeah, that's the same thing. And if we multiply that out, that gives us how do I put this? That just gives us the result of 3.047. As well as if I do 12 times 11 times 10 times 9 times 8 divided by 52 times 51 times 50 times 49 times 48. Same thing. and that gives you the result. I messed up on this problem, or had to guess, because I don't know. I thought that it was 9. There were a total of 9 royals in a deck, because I'm stupid. Woo. Okay. 26. So I forgot the outlier formula, but there is a trick, I guess. So when we have a data set, there's a few things that you want to know. We have the mean, obviously, but we also have something called the median. And the median is basically the middle number. So in this data set here, 1, 3, 5, 6, 8, 5 is the median. If we have, let's say, -1, -1. I think that if you have two numbers where the median is in between them, it's just the average of the two. But here, -4, -2, 0, 2, 4, 8, I think the median is 1. So it's 1 there. 2, 4, 5, 5, 5, 6, 8, median is 5. It's like the middle number. So then if you divide the data set into two halves, basically Q1 is going to be, or you have like the first quartile, I guess. I don't really know how to explain it that well. This isn't like my best area of math. You have Q1 and Q3. And basically they're the medians of each of the two halves of the data set. Now, the distance between them is called the IQR, or the interquartile range. So if we go to our previous data set actually that we dealt with, I'm going to actually scroll to this. Let's see. Where was this? 10, 28, 45, 47, 49. Where was this? Okay. Sorry, let me go back to one of our stats. So our median was 45. Then what's ever left over, the IQR, the quartile, Q1 here, was the average of these two, 19. Q3 was the average of these two, 48. So 19 and 48. And our interquartile range, where does it even say interquartile range here? I don't think it does. Is 48 minus 19, or 29, I think. Is our IQR there. Where the hell was I working on previously? Okay. And then what was the exact rule? Sorry. This is actually, I haven't done this math for a long time. X1 is less than Q1. So the outlier test to see if something's an outlier is basically, it's 1.5 times the interquartile range less than the Q1, or 1.5 times the IQR more than Q3. So let's go through. So here are, luckily, okay, sorry. So here are, this is our Q1. Our Q1 is 1 there. Q1 is 1, and our Q3 is 3. So our interquartile range is 2, which means that 1.5 times the interquartile range is 3. So, and if it's outside of that, it's an outlier. And we can see here that basically -4 is outside of that. So that's why it has an outlier. If we go through the rest of them, we will see that they do not have that. Like here, for instance. That's -3 is the Q1 there. 6 is the Q3. And then if we subtract those two, we get IQR of 9. 1.5 times that is 13.5. So 6 plus 13.5 is way greater than 8. And -3 minus 13.5 is way less than -4. So yeah. I didn't have time to do those. Those I kind of skipped because those seem like a bitch. Okay. $750 is deposited in a 16-year savings plan with 1.29 annual interest. How much is in the account if it is compounded annually? Okay. So 16-year saving plan. So for this, we have the formula for non-continuously compounding is going to be principal times 1 plus r divided by n, and n is basically the time period, to the n times t. And this basically is just adjusting for like the specific time period. N is basically how often it's compounded. So it'd be if it's like compounded monthly or something. So, what we do here is we have y equals 750 times 1 plus 0.0129. Because we're compounding this annually and it's annual interest, we just do n is equal to 1 to the 1 times 16. So it's just 750 plus 1.0129 to the 16th. $920.72. Okay. A loan of 4 years at 5.8% interest compounded continuously is worth $3783.36. Find the initial amount loaned. For this is y is equal to PERT to the PE to the RT. I'm going to go into numeric solver for this because I don't feel like doing math. So we have 3783.36 equals x, or whatever, p, times e to the point, come on, why aren't you working? .058 times 4. 3,000. Yeah. Okay. Boom, that's how you do that problem. Okay. Now, 29. An arithmetic sequence has first term 1 and third term 7. It sums to 376. Find the number of terms in the series. So, I actually think there's a formula for this. I don't really care. I don't want to do it. So, here's what we're going to do. We're going to set up what this arithmetic sequence looks like initially. We know that r is going to be 7 minus 1. So, it's going to be, r is going to be 3. So, it's going to be, let's say, 3 times n. And if we're looking at an, we're going to start with, let's say, or 3n minus 1. 3n minus 1. So we start with 1. an equals 1 plus 3n minus 1. Or an equals 3n minus 2. Because of the offset. Then we're going to go into math summation. Start with x equals 1. Because you want to start there when you're doing this kind of thing. 7. 3x, let's say, oh wait, actually no, we don't want to start with 7. 3x minus 2. Now it wants us to figure out when this sums to 376. So I'm just going to try out some numbers. 7, 70. Doesn't look like enough. Let's try upping this to, let's see, let's try doing 20. Come on. Can't type in zeros. I'm going to do 21. 651. That's a lot too much. 15. 330. We're getting close. Let's try 16. 376. Boom. Sometimes you don't need to know math. Sometimes you just need to know how to use your calculator. Okay. -4, -8, -2, -6, -7, -9, x squared has a mean of 0. Find the possible value of x. So, for this, we want to know our mean formula. Mean is equal to -4 minus 8 minus 2 minus 6 minus 7 minus 9 plus x squared divided by how many numbers are there? 1, 2, 3, 4, 5, 6, 7. 7. We know that our mean is equal to 0, so it's 0 is equal to this divided by 7. That if we multiply 0 by both sides, we get 0 is just equal to actually all the numbers on top. And if we, do some more math here, we actually get negative x squared is equal to basically the sum of all of that. So let's sum all of those together. Negative 4 minus 8 minus 2 minus 6 minus 7 minus 9, negative 36. And x squared is going to be equal to positive 36. And the square root of that is 6. But alternatively, they don't give us 6. So it's going to be negative 6 because, x actually could be, if you have x squared equals 36, x could actually be equal to plus or minus square root of 36. Yeah. Okay. Oh yeah, 31. I also guessed on this one. So the trick that I did here was using, if you're running out of time on this, you can make some intuitions. So remember, an outlier is likely to be really far from the main numbers. So I just said, okay, which one of these looks like it's not going to be, I actually ran out of time when I did this. Which one of this looks like it's going to be closest? And negative 9 look closer to 1 and 23 look closer to 10. So it's like, screw it, it's negative 9. Yeah. Now, if we actually want to do this mathematically, so first of all, there's two cases where x is on top, and x is on bottom. So if x is on top, that means that we have, let's say, 1, 2, 3, 5, 8, 10. We know that's also going to be larger than any of those, but yeah. 5, 8, 10, comma x, if it's like, let's say, a positive number, and if it's like 23 or 25. That means the median is here. The Q1 is 2, and Q3 is 8. The interquartile range is 6. 1.5 times IQR is equal to 9. So an outlier would be greater than 23 in this case, or less than negative 7. Nothing works there, so yeah. Also, this is only checking if something's greater than 23, because this is assuming that actually x is larger than. Otherwise, the positions slightly change. Now let's assume, because it slightly alters the formula depending on which side of the equation x is on. Just because of how you pick medians and modes. It's a little like less pure like algebra, and it's a little more like, how do I put this? Yeah. So if we have, let's say, x, comma 1, comma 2, comma 3, comma 5, 8, 10. Now the mode is actually, or the median is actually 3. Q1 is 1. And Q2 is 8. And IQR is actually now equal to 7. So 1.5 times the IQR is now 10.5. So 1 minus 10.5 is negative 9.5. So anything larger than that is an outlier. Hey, look, negative 9 isn't. And 8 plus 10.5 is 18.5. Now the other numbers work. It's negative 9. Boom. Oh, that's how you're supposed to do it. Okay. Calculate the expected value of the probability distribution below. I already showed you how to do this kind of, but I'll just do it just quickly, just for safety. Negative 2 times 3. Negative 2 times 3 plus 8 times 4 plus 15 times 4 plus 23 times 3 divided by 3 plus 4 plus 4 plus 3. 11.07. Okay. And that's how you do that one. Now, I got 33 wrong. Let's see how they say I'm supposed to do it. We can have 2 math, 1 engineering, 1 physics, 1 math, 2 engineering, 1 physics, or 1 math, 1 engineering, 2 physics. I didn't think to do that intuitively. How I did this one was, I wonder why this got me such a different answer. I did 4 times 7 times 5 times 13, I guess. Or was it 13? No. 11, 16, yeah, 13, 18, 20, which gave me a very different answer. 9, 10, so I guess they divided it by, I wonder, mine was just theirs doubled. Let's see where that came from. Oh, okay. Actually, yeah. So the difference between my answer was, you always have to make sure when you're doing these kinds of problems that you're understanding how order works. Because when you straight up multiply two things, that implies that order matters. So let's see. Let's say like I do something like, okay, what is the probability that when I flip a coin 4 times that I get 2 heads and 2 tails? Now I could say, okay, well, that's simple. 0.5 times 0.5, 0.5 times 0.5 times 0.5 times 0.5, right? Which gives us 1/16. But that is actually not the correct answer, because that assumes, okay, that's like a specific order of events happening. That would be, let's say I get, that's the probability of me getting heads, 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 or like heads, 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 tails, blah, 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 that kind of thing. But this is all the different combinations of, let's say, heads, tails, heads, tails, heads, heads, tails, tails. You know, there's like 4 different combinations of them. There's 4 different types of ways that this could happen as far as I'm aware. You could have, let's say, tails, tails, heads, heads. Maybe actually there's more than that. Let's see. Tails, tails, heads, heads. Tails, tails, heads, heads. Heads, tails, tails, heads, tails, heads, heads, tails, and then heads, and then heads, tails, heads, tails, tails, heads, tails, heads, which gives us what? 1, 2, 3. So there's actually 6 different ways that that kind of thing can happen. So what you actually have to do in that case is divide it by, basically, because the specific order doesn't matter. So in that case, you actually have to multiply it by, we have to increase the probability by 6. Or what you do is, let's see, 4 choose, what is it, 4 choose 2? Gives us 6. Same thing. So in this case, we actually have to, for 35, because I was assuming, oh yeah, you know, you choose a math class, you choose an engineering class, you choose a physics class, and then you choose one of both. But it's like, how do I put this? 4 times 7 times 5 times 13, which is what I originally did, is slightly different than basically assuming that it doesn't matter the order in which you pick this, you know? Like, let's say we had class, let's say let's say we had physics A, B, C, D, or physics 1, 2, 3, 4, physics 1, physics 2, physics 3, physics 4, engineering 1, 2, 3, 4, 5, 6, 7, E1, ... to E7, and physics, and math 1, or wait, actually that's physics 5, math 1 to math 4. This is saying that choosing math 1, engineering, let's say math 1, engineering 1, physics 1, and math 2 is different than choosing math 2, engineering 1, physics 1, math 1. Where it's like, when I do 4 times 7 times 5 times 13, 4 was for the number of physics, 7 was for engineering, 5 was for 4 was for math, 7 was for engineering, 5 was for physics, and then 13 was basically 4 plus 7 plus 5 minus 3, because basically there's only 13 possible classes left that I can choose. The way that I did this initially is assuming that these two are exactly the same, or these two are different, but they're not. All we did was switch the order of math 2 and math 1. So for that, 4 times 7 times 5 times 13, what you need to do is divide it by 2. Or divide it by, what is this? Yeah, is it just, yeah, divide it by 2, because that's the number of different ways that, like, you know, they could be combined. I think it's 2 choose 1, actually. Divide by 2 choose 1. It's probably the same thing. Yeah. Or 2. Same thing. Yeah. The way that they recommend that you do it is you can have 2 math, 1 engineering, 1 physics, 1 math, 2 engineering, 1 physics, or 1 math, 1 engineering, 2 physics. So you sum up 4 choose 2 plus 7 times 7 choose 1 times 5 choose 1. This gets you the same result. Either way is valid. Yeah. Don't worry if you get that kind of problem wrong when you're first starting out. Even I got it wrong because I'm kind of like out of touch with these. These kinds of problems are the hardest to do on the test. Okay. An arithmetic sequence is given by A1, blah, blah, blah. So find A1 and A9. So first, let's find the ratio. We know that the ratio here are 2 to 9, 7. 9, 16, 7. A1, we know that A2 is 2, so going down by 7 gives us A1 equals negative 5. And then they want us to find A1 times A9. So A8 is 37 plus 7, or 44. And A9 is 44 plus 7, or 51. So A1 times A9 is 51 times negative 5, or negative 255, I think. Whatever. Yeah. And 35. This is another kind of specific one with like a specific formula. From the formula for variance. Let me see. Okay. So there's a little mathematical trick as far as I can tell that they are using here. So let me scroll down. So I'm going to erase some things because I need some space to work this out. And this is obviously one that, you know, saved for last, which is lucky because it's last at a test. And I knew it had something to do with this. I didn't remember the exact one. But yeah. Okay. So we know that theta squared, or variance, is equal to basically sum of like I equals 1, 14 or so, because there's 14 data points here. That's what I equals 1 and 14 means. Xi squared minus mean, or xi minus 1 minus mean squared. And then all of that over n, or basically over 14, because we know that there's 14 data points. So we have, so if we multiply that out, we have I equals 114. Xi squared minus 2 times xi times x times the mean plus mean squared over 14. All of that, actually all of this over 14. We know it, so also you can actually separate summations. So we know what this is. We know the sum of that is equal to 405. So we have 405 minus, what was the there's one thing that I can't figure out how they did there. Minus xi. What? Oh, God. Why is that 3 times 14 squared over 14? I know that's, I'm sorry, I'm trying to figure this, because this is something where it's like I've forgotten how to do this for the most part. 14 times 3 squared over 14, where 3 is the mean. Yeah. I'm gonna look this up on Google. I'm gonna pause until I can figure this out. Give me a second. Okay, so I figured it out. There is an alternate formula. Also, it's kind of dark. I'm gonna turn off the light. Give me a second. There we go. So there is an alternate formula that you need to remember. So basically, the standard deviation, while it is equal to the formula that you see above, also is equal to, where you have I equals 1 to n in this case being 14, xi squared minus 1 over n, I equals 1 n, just regular xi squared. So what this is here, this right there is actually the mean. When you calculate the mean, the formal way of writing it out is the sum, or this actually, not exactly the mean, but basically just the sum of all the things above the mean. So you have, also actually this is standard deviation squared, so this is theta squared. So it's the sum of everything above the mean. So, all these points here, like 1 plus 3 plus 7 divided by 2, or 1 plus 3 plus 7 divided by 3, if you have the points 1, 3, 7. It's the sum of this. So we actually know what that would be. We know it has a mean of 3 and that there's 14 data points. We also know what this is exactly because they give it to us. 405 minus, we know what 1 over n is. 1 over 14 because there's 14 data points. This here is going to also be equal to the mean times the number of data points, 3 times 14. Or actually, you know what? I'm going to write that out better. So theta squared equals, I'm going to write out the original formula up here better, so in a way that's more understandable. Mean. So theta squared equals I equals 1 n xi squared minus 1 over n mean times n squared. Hopefully that makes sense. This is the mean times n squared. That's the alternate formula. So we have 405 minus 1 over 14 times 1 divided by 14 times 14 times 3, because our mean is 3 and there's 14 data points, squared. And that gives us 279. And then, wait, no, that's wrong. Wait, did I fuck up somewhere? I definitely fucked up somewhere. Oh, actually, it is actually, this is all apparently over n as well. So it's actually everything is over n. So it really should be theta squared equals I equals 1 n, 1 over n times 405 minus the mean. I think. Does that work? 405 divided by 14 minus 3 square root, and it's 5.09. No, did I fuck up? Let me see. That fucked up. Or it's minus 3 squared, so it's minus the mean squared. Minus the mean squared. So it's 405 minus 14, or divided by 14, minus 3 squared. So you take the sum of all of basically the number squared, this thing here, 405, divided by how many terms there are, 14, then subtract the square of the mean, which gives you 19.92. Take the square root of that. 4.46. You learn something new every day. It's kind of written in a weird notation that's really not usually that applicable online. But yeah. This is the original formula here. Or actually, it's that. Then you have theta squared equals I equals 1 n xi squared minus 1 over n I equals 1 n xi squared divided by n. But I'd really recommend, what is this? Where did I write the really good formula? I'd really recommend using I equals 1 n, 1 divided by n, theta squared xi squared. So it's basically, they're usually going to give you this thing if they want you to use this formula, minus the mean squared. Okay, and then, yeah, that's how you do that problem. 4.46 is your answer. Okay, what was the problem that I was struggling with up above, or that I was like, yeah, we're going to get back to this. It was this bad boy. Okay. So we take 300 what's the sum of this? I'm going to do this actually the way that I know how. There's actually a summation. If you don't remember the annuity formula, there's a little trick that you can use. You can do x equals 0, I guess. Come on. And then how many months are there? Let's try 14. Um, 300 times 1 to the arrow 1 plus, or it's actually 1 plus 0.025. Come on. To the, what is this? 14 minus x. This is basically summing up all of the additional ones. It's not really a good way of doing it, but I want to try this out first. I really think it should be 13 or 14 or whatever. Let me see how they did it. Which one was it? 8, okay. Yeah, oh no, it's actually me that's been messing this up. Let's see. It's actually 0.025 divided by 12. That's the issue that I run into here. Divided by 12. Because that's the annual rate, you want the monthly rate. That's one of the things that you need to remember about this. You need to convert into like monthly rates and that kind of thing. So that gives us 13 doesn't work then. This is like, yeah, you need to make sure that you're converting into the right rates. Let's try 16. And yeah, the actual formula that they want you to use is the annuity formula. And the annuity formula, where is it? Is it on here? The annuity formula is this bad boy. This is money of growth. You don't really ever want to equate these. That's really not something you need to do that often. You really want to focus more on what each of these individual ones mean. So M is the compounding rate, and the annuity formula that you have here is A, 300, which is the amount that you're adding every month. 1 plus R, our rate is 0.0 is 2.5 or 2.5%, or 0.25. The basically the time period that you're doing it over, how often you're adding the amount of money. Oh, what the hell? Ugh, oops, my pen was rolling around on the paper. That was messing it up. So 1.25, and we're doing this every month. We're adding money every month, not every year. So you need to be careful about that. And then the period of time, I guess. The M times T, this is, you can just actually do the number of months. You don't need M times T. That's just, if you want to do M times T, that'd be 12 times the years, but we're looking at everything, where's 8? We're looking at everything in terms of months. That is the one R over M and to the MT and all these problems, that's just converting between annual compoundings, annuities, to monthly to weekly, etc. Whatever the time period that you're looking at is. So this is 12, or it's asking us to test specific numbers. So times 12 minus 1 is the formula. You subtract 1 from that, all in parentheses. Let me add in a parentheses. And then divide it by the rate per time period. So that's going to be 0.025 divided by 12. $36.41 over a period of 12 months. So that doesn't work. Let's try 17 months, which we know is the right answer. I'd actually plug this in to the calculator and see what works. 51.85, so that's the right answer. Okay. I think that's actually all that we have to cover. Yeah, kind of different. This is pretty difficult. Hopefully you get better at this over time, as will I. I really hope I do better next time. And yeah, let me know if you have any comments, any things I should improve on for the next time, and I will hopefully post this on YouTube pretty soon. Okay, thanks.